So the objectives are, what is Spark, why Spark? Those are some of the things wherein, you know, there would be some of the references, especially those people who are already working in big data domain. They would be able to correlate to it very easily. And then we'll dive into something called Spark ecosystem. So there is something good about Spark, that it's not a specialized big data system. It's a framework. It has its own ecosystem, just like Hadoop has. Then there will be a small note about Scala, hardly I think one slide about it, and then why Scala. So now let me just get started with. So what is big data? Now this is some. I'm assuming that out of, just a sec. Yes, out of almost, you know, these 75 plus guys who are right now here, almost 20 to 30 people know about it, but then there are so many people who don't know about it. To make it pretty simple, it's about lots of data. Now this lots of data seems to be a very abstract term. So all I would just say is, some year back, when you must be hearing from your database administrators and all, that if the database file size of whatever database you are handling with is in the order of several GBs, then you are actually talking about a big data instance, quite a big data instance altogether, right? But right now, that is scale. So 3-4 years, earlier, the scale was at several GBs. Right now, as kind of an industry standard, and I'm not talking at the level of Facebook and Google who have moved to the petabyte scale, but at the industry standards, high side of GBs means, 500 GB, 600 GB kind of volume, or early. So I hope you must be getting an idea about it. So it is volume, of course, yes. But what exactly, so is the volume only thing which makes it, which makes your big data world altogether different? There are some other aspects which are, which come along with it. You must have heard about, that famous 3V thing altogether: volume, velocity, and then variety. I will come to that part because that's more of a theoretical thing. It's all about is when you have so much of data, then it becomes very difficult or sometimes almost impossible to handle it with the traditional applications altogether, or that traditional monolithic servers or applications which tend towards the vertical scalability. When you talk about vertical scalability, you are talking about increasing the strength of an existing machine so that it can, support more data, it can have more processing power altogether, invest more money, keep on increasing the strength, but again, there is a limit to it. So, sorry. Typically, all of the distributed processing systems, they work on the horizontal scaling side, wherein they say, okay, we are not really going to invest too much on each and every machine. Instead of that, can we have a cluster of, some relatively cheap machines? They are typically called, the term for that is commodity hardware, and can we do the distributed processing to achieve the same results in much lesser investment altogether? Of course, it leads towards, its own challenges. So those, apart from those 3V challenges, which you must have heard about: volume, yes; velocity, at the rate at which you are capturing the data or probably processing the data; and variety. When you talk about variety, it is about you are dealing with structured data, unstructured data, semi-structured data. Apart from these 3Vs, when you go to the distributed world, distributed processing world, which you typically use for the big data, you encounter different kind of challenges altogether. You talk about distributed processing, then how exactly you are going to maintain the states, how exactly you are going to deal the failures or probably partial failures, then fault tolerance, and all those things come bundled along with it. So these are some of the factors, again, at the very, very high level, these are some of the factors which make your big data world completely different from the perspective of your traditional world as such. Okay. The challenges, of course, you are dealing with such a huge data, be it the capturing side of it, be it the data messaging side, be it the sharing of information, searching, transfer, analysis, even the visualization, right? So all of these things face those typical challenges. Your typical way of working doesn't really hold anymore here, right? Because you cannot really perform a select star from a specific table, whereas that table is having, let's say, around billion records, right? So you are not going to get fast responses. That's the simplest example, but yes, there are various others. So I would not spend much time on this side. I hope you would have got some idea about kind of challenges which are involved here, right? Now let me come directly to Spark. Before this, just for the people who don't know about big data world, I would highly recommend if you could spend some time on Google or wherever study material. Just see what exactly do you mean by the batch big data processing. See, batch processing is one and batch big data processing is other. There is a difference. And then something called Lambda architecture. Okay, that would give you good idea about why exactly you should even go for something called Spark or probably Storm. So coming to so this is something which I would leave for those people who are not aware of this. Now coming to Spark. Spark is typically used for near real-time processing or for very fast batches altogether. Okay. Now before coming to where it is used, let me come to what exactly is it. So as the first line says, I'm not a fan of reading out the slides, but sure, since it's kind of a definition itself, right? So Apache Spark is a general purpose cluster in memory computing system. Good. What does it mean? What does it mean? So let me just break it down. Apache Spark is a general purpose computing system. So must be sounding something like Hadoop, right? General purpose cluster computing system means almost like Hadoop, right? So it's a general purpose cluster computing system. You're talking about distributed processing, and the moment you talk about cluster, most of the times, more or less, it is going to be commodity hardware. And the only difference is it's in-memory computing system. Now, when you talk about in-memory computing system, you typically are going to perform your calculations in the distributed fashion, but your operations are going to happen in memory. Not really strictly in memory. There are various options which are available. I'm sure those people who are from big data world must be thinking, what if my data which is there in a specific node doesn't really fit into memory? I'm sure some of you would have thought about it, right? But for now, just assume that yes, it is gonna fit, though there are of course in practical it is not, and then there are options also available for it. Okay, so we can come to those parts when we'll be talking about we'll be discussing Spark in details in the classes. But for now, it is the general purpose cluster in memory computing systems. Your most of the calculations happen in memory altogether. Okay, and then this is one. Since the calculations are going to happen in memory, they are going to be much faster because you are not reading the data. You are not doing the on-demand paging altogether. You are going to perform the calculations in memory, so they are going to be much faster than typically they are in Hadoop. The other thing is you so Spark provides the high-level APIs as well in Java, Scala, and Python. So it's like it's polyglot in nature. Polyglot means multiple language support altogether. So Spark provides you the support for, as of now, the language is support is for these 3 languages only. So if you must be having a question, can I write a Spark program in C++ or JavaScript for that matter? Not as of now. Probably not as of now. Probably there would be some support in future, but not right now. Now, I'll come to why exactly on Scala and all. So it is quite an optimized engine which supports the general execution graph. Again, it's kind of a very abstract statement. It's all about, guys, that Spark follows something called lazy evaluation altogether and lazy execution. It's all about, if some of you have worked in PEG, you must be knowing that it typically goes for the lazy processing. Until and unless you force an action, whatever calculation you have done, that is done logically, that is not actually invoked on the data. So that leads to a big performance optimization altogether. Okay. Now, these are the 2 points, but the third point is even more important, which differentiates the Spark from others. So it is about Spark provides you the high-level tools like Spark SQL for structured data processing, MLlib. There is a spelling mistake here. It is written as mlib. It is not. It is MLlib, machine learning library for machine learning and more things. Okay. So as you can see in this figure, Spark goes for high-level APIs, high-level tools, and many more things. There are some of the other features which will come. So now coming to why Spark. Okay. So there are various reasons. I think one reason which is mentioned here in the slide doesn't really give you enough, or see, for me, if I'm going to spend my time and money to learn something, I should have a reason behind it, right? So it's about why Spark. This is one thing. But guys, let me go off track a bit, and it's kind of a deviation, but yes, it would help. See, most of you would have heard about Hadoop, right? Hadoop is typically good for batch processing of huge amount of data, big data altogether. And then it's quite flexible and so many things altogether, right? Now, why Hadoop has become so popular? Initially, it was not. Of course, it has got some popularity over the period of time. And also, you must have got a clue when you were typing, whether you have worked in big data or not, or probably some people who have worked in Hadoop or not. The reason is Hadoop is a framework. Hadoop is not a specialized tool. What I mean by that is, what is a framework? Framework provides you various utilities or tools to do what you want to achieve. So similarly, when it comes to Hadoop as such, it provides you various utilities to store the data. It provides you SDFS to calculate, to basically process the data. It provides you a paradigm called MapReduce. Of course, in 2.0 it has changed a bit, but let's stick to the very basic vanilla versions altogether, right? And for the data ingestion, for the data export, it provides you scoop, flume, right? Copy from local, that plain old copy from local. For almost SQL processing, it provides you Hive, right? So for that, so the point which I'm trying to prove is that Hadoop has become so popular because it's a framework. It is not a specialized system. It is not that, hey guys, can you perform SQL queries on this huge amount of data? Let's take this solution. No, it is a packet of all, or it's a bundle of all of those solutions built on the top of those two core components, right? And that's why it is popular. But then there are various specialized big data systems altogether. You must have heard about Cassandra. Cassandra is a close cousin of HBase and nothing else. But yes, it has got certain advantages as well as some disadvantages. Or you talk about Storm. Storm used to be considered as a very close competitor of Spark. In fact, before Spark, so when I initiated this course of Storm at Edureka, we were quite excited. In fact, we went for one particular project in production. Now we are planning to move it to Spark. Anyway, the point is, Storm, again, it's a fantastic system, but again, it's a specialized big data system. It is typically used for the streamed data processing and nothing else. But then the biggest differentiator when it comes to Spark is it's not really a specialized big data system. You must have seen some of the glimpse earlier. You will see it in bit more detail in the coming slide, wherein you must have seen that we talked about Spark SQL, we talked about MLlib, right? So what exactly are they? They are the different tools to do different things. You want to perform some sort of machine learning algorithms, you want to apply them, you have MLlib. You want to do some sort of SQL analysis on kind of structured huge volume of data, go for Spark SQL or Shark for that matter, right? You want to do some sort of stream processing, go for something called Spark streaming. I'll come to that very soon. So the biggest USP for Spark is it is not another big data or specialized big data system. It is actually a framework in itself. Okay. In between there is a question. I'm not taking many questions, but there are kind of, this is a repeated question which is coming, and latest one is from Sharath. So for R language, is there any support for R language? So let me just tell, there is something called Spark, so basically R Spark or Spark R. Okay, for now it is not even released, but it is still kind of WIP. Okay, so just like you have R Hadoop, etc., right? So guys, definitely you can just type, your questions. Only thing is whether I would be able to answer them right away or not is a question. It's a different thing, right? So if I'm not able to at the start, if I'm not able to answer them right away due to the time constraints and all, we do have the Edureka, handle. I will repeat that Edureka handle at the end, wherein you can post your questions and you can get the answers. Okay, I'm just kind of taking only very common questions, kind of right now. So that was the first USP. Now coming to the second one, it's about it is not just the framework thing. It is, so when it comes to Spark, you want to run it separately. You can run it as a using a Spark cluster manager. You can have its own cluster. Spark has its own cluster manager, Spark cluster manager. It can run on a cluster of machines without having any Hadoop, without having anything. You want to take the advantage of Hadoop either from the storage side or from the processing side, go ahead. You can integrate it with Yarn, and then Spark seamlessly integrates with Yarn. Though seamless is a very flashy term. Of course, if you're talking about open source world, so there would be some nits and grits here and there, but still, right? Or you can have the other kind of cluster manager. It is quite popular, but in fact, neither I have used nor we are going to implement it within the course. That integration of Spark with Apache Mesos. Apache Mesos is another cluster manager which you can use on basically as a it's a cluster manager, and it can be integrated with Spark. So in the course, we definitely are, so by default Spark cluster manager anyway comes, and we will be showing the integration with Yarn as well. Okay, in fact last week only we completed it in the batch. Okay, so these are some of the good reasons, I would say. Not only, so this is not the only reason. Other thing is why Spark. Again, this is more or less is the point which I have already covered, that Spark is polyglot. Right now there are 3 language supports: Java, Scala, Python, and the focus for us would be Scala. Why not Java or Python? I'll come to that later. Okay, now just continuing the very same discussion of why Spark. So Shark. Now I think I should have updated it. So by the time I started the batch, the first batch, and right now when I'm taking this session, Shark has closed. Okay, when I say Shark is closed, it doesn't mean that it means that it is no more valid. So let me first tell what is Shark. Shark is equal to Hive plus Spark. Okay, so the entire reason for developing Shark was to integrate it with Hive, so that those Hive queries, SQL queries and all, which used to run very slow, I mean not slow, they were quite fast, but again for the medium set of data they were relatively slow. So could we speed it up? That was the whole purpose. So Shark is equal to Hive plus Spark plus Hive, they typically call it as Shark. That was the project which was developed, and it is quite popular as well. It is quite popular. But recently, not recently, probably some months back, but you know, some months are recent for us in Spark community. It is kind of long time back. Okay, so Spark has become a top level Apache project. Earlier it was developed by Databricks and all, and now it has become the top level Apache project. And then what they have done is, there are some of the issues with the open source with Apache standards and whatever standards were followed for Shark. So they are changing the source code, and the next release, or I would say Shark, will be succeeded by something called Spark SQL. So many of if some of you have Googled or done some research on by your own, you must be wondering what is Shark, what is Spark SQL. So Spark SQL is going to, it's basically the successor of Shark and nothing else. Right now, so Databricks and Apache have said they are going to stop it. So there is no further development which is happening, but the support for current Shark is provided. The reason, because Spark SQL is right now not integrated with Hive. Spark SQL, using Spark SQL, probably you want to read some JSON data, you want to read some sort of let's say plain text files and all in the form of some tables, you can do that. But right now it is WIP kind of. So till the time Hive is integrated with Spark SQL, it is Shark is gonna continue for some time, and after that you will see that the GitHub repository for Shark would be closed. Got it, guys? But anyway, coming to the point that Shark, yes, you talk about Hive queries, it makes them, in some cases it is almost 100 times faster. You will see some example today all as well. Okay, for some certain applications, Spark is definitely, we have seen, I personally have seen, Spark is almost 100 times faster than the Hadoop MapReduce application altogether. Okay, so just to summarize it, so why Spark, right? It provides you powerful caching and disk persistence capabilities. Powerful caching, I'm sure you are able to correlate it with that in-memory applications and all, and then disk persistence capabilities, right? So it can persist in the disk as well. Okay, it allows you for the interactive data analysis. Now, when you go to Hadoop and all, you typically talk about, you have to submit a batch, and till the batch is done, is over, you never know what exactly is going to be the result, right? It's kind of a black box processing which is happening in front of you. But here, so it is always good to have some sort of interactive data analysis altogether, right? Using Spark core engine, it is quite possible. Okay, then your faster batch, again something which is already known. Now there are certain kind of algorithms which you cannot really implement in MapReduce. Talk about recursion, right? If I ask you to implement a Fibonacci series, you will not be able to implement it, right? The reason is because it's a recursive kind of an algorithm altogether. There are several asynchronous algorithms, iterative algorithms. They are not really possible to do in MapReduce world, but yes, you can achieve them in Spark. I'm not saying Spark is going to support all of the other algorithms also. It has also got its usual limitations of the distributed systems, but yes, many of them are quite possible. Okay, real-time stream processing. This is where Spark has got that knocking power over Storm, wherein Storm, here Spark becomes a superset of a Storm, or rather than I would go opposite way. Storm becomes a special use case of Spark, okay, wherein it typically leads to this real-time stream processing altogether, and of course all of that typically leads for the faster decision making. Okay, so these are some of the reasons why Spark basically. Okay, other thing is about your community. So Spark community is something which is super active. You can actually see that this is something which we have not produced. It is typically straight out of the GitHub repository commit. So it just tells you how many commits have happened. If you see October 2011 and all, they have basically, by the time it was kind of being formalized, and only a handful of the developers were working. Around 2012, again, there was hardly anything. Then all of a sudden, around 2013, and right now it's about 2014, you can actually see what exactly is the overall, commit rate, which is coming up, right? So this community is quite active, and when it is quite active, it looks good, but you are all developers as well, right? Or probably some senior people. You must have seen all of that. When you talk about super active, of course, it means right now the system is also a bit turbulent. When I say turbulent, it's like every release something or else would start kind of working, or there would be some of the features, of course, which would not be working so well. They are right now fixing it up, but we are hoping that very soon all of that would be stabilized kind of thing. So to tell more about Spark from the good things, but you should always see what exactly is right also, right? So the recent release of Spark, there is some problem in Spark SQL right now, which will be probably very soon. I think it will be fixed kind of, within a week they gonna fix it as well. So they always tell when a specific version becomes stable, they say that okay, now this is something which is good to download. Okay, so but anyway, the idea was to tell you that yes, this community is quite active altogether. Now this is something which I was talking about some time back, that Spark ecosystem. Spark is something which is not a specialized system altogether. So it is a framework, and that's what we mean by a framework, right? That's what we mean by a framework, that you can actually see here that at the bottom of it, you are having typically just like any framework, you should have a core engine, right? Hadoop, you have a core engine. You have two core components. From the storage side, STFS, from the processing side, MapReduce. So similarly here as well, you are going to have a Spark core engine, and then you are having multiple wrappers on the top of it. You have Shark, I would say Shark / Spark SQL. Okay, just to correct it. I hope you are able to correlate, right? So Shark or Spark SQL, Spark Streaming, MLlib, GraphX, Spark R. Probably somebody was asking about Spark with R. It is not yet released, so you can see that this orange color thing, they are still on alpha or pre-alpha release. Okay, BlinkDB, Approximate SQL. Okay, so now what exactly they are? Let me just give you a brief hint about them, and then let me tell you some more things which are kind of which you should expect in coming future altogether. Okay, so come to Shark. I think I have already told you, you have to do, let's say, some sort of SQL analysis on the structured data in a very fast manner. Shark is your answer. You want to perform some analysis on the data which is coming in the form of streams. Now this live streaming data might be any data which might be coming from those distributed messaging systems like Kafka, ZeroMQ, etc., etc. or probably you just want to create some sort of file watching capabilities, wherein as and when there is any data which is returned to a file or to a directory, you should be able to do something, right? So they are typically those streaming kind of operations. Yes, you can perform all of them using something called Spark streaming. Then machine learning, MLlib. MLlib is something which is again, it is a machine learning library which is which is built on the top of Spark. And of course the biggest advantage which you get is your typical machine learning algorithms. If so, what is the machine learning library for Hadoop? It is called Mahout, right? And Mahout is quite good, but again MLlib can perform the very same machine learning algorithm, or can implement the very same machine learning algorithm almost 100 times faster than Hadoop. In fact, as an inside information or whatever, that you can, the next version of Mahout, they are basic, or I don't know next when it would be released, but the next thing what they are trying to do is they are trying to port entire Mahout functionality into MLlib. Of course, everybody wants to take more power, right? So MLlib is something which has evolved. It has got some machine learning algorithms available, not some, quite a few I would say, but still it is not yet that much enriched as Mahout is, right? Because you can easily see that, I mean, if you see the release dates and all, they are hardly some 1 year back, whereas Mahout and all are since last almost 4 years plus, right? So just they are maturing over the period of time, but at the same time they are becoming much better, right? Talk about graph computation altogether. So you must have seen Neo4j, Giraffe, GraphLab, etc., etc. So typically it's in the, so again, Spark gives you the utility to perform your distributed processing altogether, right? Distributed graph processing. Not related thing, but yes, before graphics, it used to be called as Bagel. Okay, so it was, I mean, just 1 year ago, it was released as Bagel. Then it got changed to, I mean, it will be succeeded by graphics. Again, it is in the transition phase right now. And SparkWire, I think I just told about it. Just like R Hadoop, people who are from R background, they want to utilize the power of Hadoop, right? They typically go for R Hadoop, and which is typically by Revolution Analytics, and now they have the, this thing with Cloudera. But yes, that is in the Hadoop world. You talk about Spark with R, Spark R is your answer, right? So these are some of the things which are coming up. In fact, what I heard latest was that just on the lines of Hive, people want to move Pig also, right, to Spark itself. And if I'm correct, as of now, they are calling this project as Spark, S-P-O-R-K, Spark. Okay, when it would be released, when it would not be, I don't know about that, frankly. But yes, it is kind of, a project which is already going on right now in Apache. So you should hear something about it, right? So anyway, that was just to give you an idea that yes, this ecosystem is something which is just enriching over the period of time. So guys, how are we? Are we good? Because we are almost 3/4 of our entire time. Was it useful for you? Now, because I'm now moving to the next section of it, right? I hope it has added some information to your existing repository altogether. That was my purpose, right? Is there anything in the lines of HBase? Actually, that nothing is required on the lines of HBase, because it. So you can think about Blink basically. No, actually, you don't really have anything in the lines of HBase. Actually, you don't even require with Spark. You will realize it. This is, I would say, this question would not be valid when you learn what exactly is the use case of Spark. Okay, Satish. Spark is something will take over to Hadoop. No. So many people who are asking this question, that it means Spark is going to is going to take over Hadoop, going to replace it. No, guys. That's why I at the very start I told, or I requested to kind of search for something called Lambda architecture. Okay, that would give you more idea about how exactly they are going to coexist and how exactly they are going to complement each other, right? So just an answer to most of you people, right? Okay. Somebody is asking about the question about what exactly is MapReduce equivalent in Spark. So guys, actually I'll move to this question now. So nobody has asked me this question, okay, and I am going to answer that in a few more minutes. Okay. Now, a note about Scala. So guys, again, Scala is just like any other programming language, yes, but yes, it is typically called as improved Java. Okay, and it's a general purpose programming language altogether. But why are we calling it as improved Java? Look at the second point. Scala supports both object-oriented programming as well as a functional programming paradigm altogether. That's the biggest advantage which you get with Scala, because you talk about typically those distributed processing systems altogether, then you don't really code in the object-oriented way. You must have seen it. You must have observed it in the terms of MapReduce programs. If you have written earlier, you must have seen those kind of design patterns which come along with it. You don't really, I mean, applying object-oriented programming concepts is not really a very good way to implement them. So that is one of the main reasons it lags. Though underlying framework is written in Java for where you need those classes and those kind of object-oriented programming concepts altogether. But when it comes to the MapReduce kind of applications or most of the distributed applications and all, typically people have found that functional programming is something which is quite good. It's not really the object-oriented programming. And then there are other aspects which come from the concurrent access, and then it becomes very, very difficult to manage the concurrent objects and all in the object-oriented programming world, wherein you can change the state of something. Whereas when you go to the functional programming, since you have the basic, so what exactly are the two paradigms of functional programming? What exactly are the two main paradigms of functional programming, guys? I mean, I'm not asking, it's not mandatory to answer it, but if somebody knows, you can just type it. So there are the two fundamentals are that your functions, okay, your functions are the first class citizens. When you talk about first class citizens, you will be treating your functions just like any variable altogether. And the other one is entire objects are immutable. So it's almost kind of string. So if you change something, you are not going to change the object per se. You are not going to change the state of the object per se. You are going to create a new object, and that immensely simplifies the problem of concurrent programming altogether. Anyway, that's a separate topic. Sorry, I sometimes kind of deviate a bit, but yes, it is about. So with Scala, the good thing is it supports both kind of paradigms altogether, and it is not that we are just going to learn Scala only for it, only for the sake of this course. No, guys, it is very much in the fabric of most of the future. If you talk about future big data frameworks altogether, or some of the existing ones, Scalding, talk about Spark, which you are going to learn, or some of you who will subscribe to it, right? Or Akka is another one, right? It's actor-based, multi-actor-based kind of framework and all. So they are typically all of these frameworks are completely into written into Scala. So of course, all of the example, this note is also important, that all of the examples in the class will be covered in Scala, and we do know that most of you would not be coming from that background. So of course, how exactly we have defined this course is that first 4 classes would be focusing on Scala, to give you good enough information about how to use it for the programming, the bare essentials which you need to know. Of course, we will not be telling you what is for loop, what is for while loop, and all, right? Because that is something which you know already. What you will be telling is how exactly they are going to be different in Scala from, let's say, any other programming language, or let's say from Java altogether, right? So in the previous batch, I always have taken those parallels from Java. Okay, this is how you typically do it in Java, but then when you come to Scala world, this is how it goes. Different altogether, right? So that's the overall plan here. Okay. Now I will come back to the question, that question which was asked to me earlier, that what exactly is the MapReduce equivalent in Spark. So with Spark, you generalize your MapReduce program. When we talk about map, so there is something called .map, .reduce. These are some of the inbuilt functions which are provided by something called RDDs and all. Okay, they are the, you can treat them as Scala data structures altogether. So you can perform them. The map, map phase, reduce phase, you can do all of that. Okay, so they are just the functions which are provided by the RDDs. Is that clear? Siddiqui, Shajat Siddiqui. That exact question was by you, right? And then the good thing is you don't really need to do only MapReduce. You can perform more, several other operations as well. Okay, so more on that. It's not really the right time to talk about, what exactly are the other operations possible. Okay, now why Scala? Again, I have talked much about it already, that it's all about, it is a pure object-oriented programming language, as well as it supports a functional language. And of course, the good thing is you can call Java code from Scala and vice versa as well, right? You can do all of that. Yeah, and of course it is going to be available in most of the future frameworks. That's fine. So no more time on this. So now I'm actually coming to the point of showing you a small demo, okay, wherein I'll be showing you a simple program which I'll be first executing in MapReduce. Our typical Hadoop MapReduce, every parameter will be the same, means our input file will be the same, okay. And with Spark also, I'm going to fetch the data from HDFS. Though by default it fetches the data from local, but just for this use case, I'm going to fetch it from HDFS altogether. Okay, and then we will first run it in MapReduce. That simple word count, right? With word count, the good thing is I don't need to tell many people what I'm trying to achieve, right? So you will see that time, and then very same file we are going to perform, or we are going to execute the Spark program on it, and then we'll see the execution time. Looks good? Okay, so let's, without wasting any time, let me just get started. Sorry, some of my code files. Great. So guys, I'm right now in Hadoop, and just to save the time, first let me tell, this is my HDFS thing. Wait, Hadoop fs -cat Control-Shift-V, and let me just show you whatever. This is 20. So this is showing you basically an input file which is having some words altogether. So just to tell you, I have kept only 3 names: Vishal, Vikas, Vijay, and they keep repeating over and over again and again in this entire text file. Okay, now the word count is going to tell you which name has occurred how many times, right? So, and shift home, just to save the time and avoid any typo, I keep my commands ready. Okay, so this is those people who are from Hadoop world, they know already. That's right. So Hadoop jar, I'm running this inbuilt example, MapReduce example, word count. This is my input /inputs. Spark input, words underscore input, op underscore dir is the output directory where I'm creating my output, and let me run it. Okay, sorry. Now let me go. Sorry, so many things. Okay. All apps. So guys, this program just got completed. Let me just show you. Come on. Yep. See this. Right? Word count. If you see this, start time, end time, etc. But have you seen this? What is the time which was taken? 23 seconds. You can see that it's quite fast. Right? Everybody has seen 23 seconds. Right? Let me show you the output as well. So the output of it would be Vijay 22, Vikas 44, Vishal 66. These are the frequencies of these words. Vishal appeared 66 times, Vikas appeared 44 times, Vijay appeared 22 times. Right, guys? Are we good with the Spark example? Sorry, with the Hadoop example, wherein it's a simple word count. We have seen that it takes 23 seconds, and we got the output as well, right? Now, let me run the very same example in Spark. So in order to do that, I will open another terminal. Okay. Come on. Rather than doing it here. So this is putty through which I am capturing my machine. Just for a better view, nothing else. Spark. This is my typical Spark directory. I will go and fire up the Spark shell here. Okay. So I fired it up. Now it has basically, so by default it gives you that Scala REPL altogether. Now let me just run my instructions to it. It's kind of an interactive thing. So first thing is, I'm not explaining the meaning of each and every each and every of my statement altogether. Is you can just see that val log file. You can see this. I am fetching the data from HDFS, and you can see that slash inputs, Spark input, words input. It's the same input which I have taken for my MapReduce job. Done. Now, so I'm not going to explain much about this right now. I'm just to tell in MapReduce terminology, I'm doing the tokenize operation. Okay. So these are some tokenized operations which are happening. Then this is the map stage. I could have achieved all of this in a single line. That's another beauty of Scala. And right now you can see that some of the things are happening, but no actual calculation. This is like logical way. Scala is just basically Spark is just ready to perform the calculation, but it has not really performed anything as of now. Okay, this is the reducer side output. So when you run it, there is no output here as such as of now, because all of this, okay, all of this is something which is kind of calculated, not really. I mean, sorry, kind of, a DAG is prepared, but no actual calculation is forced. Now when I try to say reduced OP dot collect, now the calculation would happen. So let me run it. Over. See the output. Vishal 66, Vikas 44, Vijay 22. Can you see more than this? Can you see the time? You saw 26 seconds, and then you are seeing 0.044 seconds. It is right in front of you. Saw that? Everybody? 0.044 seconds altogether. So now it is up to you to see that what exactly is the difference which you saw. It's the same word count. I didn't do anything, right? It's the same word count, optimized one, not written by me, right? Pre-shipped example takes 26 seconds on the same data set, and the same one in Spark takes less than a second. Right, guys? So with this, my coverage for the session ends, and I just hope that you found it useful. Thanks a lot for attending it. Logging off now. Do provide your feedback, guys.